Welcome, everybody. Thanks for being here. I'm excited to be introducing the agentic interfaces that we're going to be creating or have created for Yugabyte. And in particular, I'm going to go over performance insights, the performance advisor for Yugabyte, and how we've integrated AI into it. So my name is Kyle Hailey, product manager for observability at Yugabyte. And I've had a history of database performance monitoring for about 25 years, designed the performance manager, the performance pages in Oracle's Enterprise Manager, as well as at Amazon RDS, designed performance insights. And then at Datadog, worked on DBM, their database product for monitoring databases. So now with the advent of AI, database operators are looking different. So systems were, of course, built for humans, and the priority there was building interfaces that were easy for humans to use. But now we're bringing in AI counterparts. So how are these being built? So AI is redefining our interactions with data. AI agents are like the new kind of data employees. So each role, ideally for each role, we're going to have a data AI assistant. So if I'm a developer, there's tools like Cursor or Windsurf in the industry, but they don't really have much information about Yugabyte. So we're working on supplementing those development IDEs to have information about Yugabyte, so a developer can work with those IDEs and get assistance on how would you create schemas differently for Yugabyte than another database, or just general questions involved in development. And then for operators, if I'm like deploying a Yugabyte cluster or adding nodes, we're going to be building an AI assistant to help all those operations automatically. And then for end user, having an end user assistant to ask questions and get nice answers. So I don't know if you can imagine a world where we have an autonomous DBA agent. So like a mission is like an SRE or DBA that is constantly there ensuring reliability and optimizing the cluster. So the responsibilities of such an AI agent would be like DB health, diagnosing issues, tuning performance, working on security, planning on capacity for the cluster, and proactive maintenance. And there's some additional roles. It could perform platform migrations and do initial deployments. So AI adoption is changing the way we work. Developers need smarter tools constantly. Operators need predictive intelligence. And one of the most important things is enterprises need confidence that the AI can safely interact with production data. So Yugabyte's already started a number of initiatives. We have AI in the documentation system. We're creating a copilot for Voyager, the migration tool, to provide AI assistance. We have an MCP already available for interacting with the clusters. And then we're adding a copilot to Performance Advisor for optimization of the database. So the documentation is already enabled and available, the AI assistant. We already have the MCP server out. And what we're building right now, or we're going to demo live in the demo grounds and here in this presentation, are an AI assistant for Voyager, the migration tool, and an AI assistant for the Performance Advisor. So here's the kind of architecture we're imagining. On the right, we have all our clusters, whether it's Yugabyte Aon, Yugabyte Managed, or Yugabyte Anywhere, or just the OSS database. We already have the Yugabyte consoles, where you can connect directly to the clusters. We already have MCP available, where you can connect to the clusters with AI assistance. And then we're building these multiple agents. So we're building an agent for Performance Advisor, an agent for Voyager, the migration tool. We already have in green, the Docs AI is already available. And then we're planning on building a YugabyteDB provisioning agent, so provisioning the clusters, allocating nodes, different operational tasks. A schema AI, which would be for like developers. How would you create the schema in an optimal way for Yugabyte? And then we have the MCP server, which is already out and available. And then we want an AI orchestrator level that talks to these agents. Maybe talks to one, so it takes in the user's question, channels it to the right agent. Maybe it uses multiple agents. And that connects to the universes. So in green, they're available. In yellow, they're in progress. And the white's what we're designing right now. So one of the products that we're introducing a copilot to is Voyager, which is our migration tool. So the migration tool makes migrating from one database into Yugabyte simple. We have a number of databases you can migrate from, Postgres or Postgres compatible, like on Aurora or GCP, Oracle, MySQL. And what it does is it looks at any schema changes automatically for you. Are there any data types that aren't supported? Or maybe a data type needs to be changed from int to big int or something. It goes through all these and assists on like any changes that need to be made before you do the migration. It estimates the size when you come into Yugabyte, what's the size that we need to expect for that database, and the performance. It looks on the source database, sees what performance is like there, and then we can compare it to the performance on Yugabyte, and it estimates migration times. So this can be done offline, or it can be done live migration online. And then we're introducing the copilot, the AI assistant. So the copilot will take any complexity out of it and make it simple. So end-to-end migration assistance, AI-driven schema and script automation. So it makes the whole experience simpler and faster, and it provides confidence to somebody doing the migration. So this demo will be available in the demo grounds. And then what I'm going to talk about and do a live demo on is Performance Advisor. So here's the basic architecture. The front end is like the Yugabyte console. Then behind it, we have a fast API server that comes into an AI orchestration level because we have multiple agents. Like in orange bottom left, that's the live cluster, your database. So we can connect directly to it and run things like an explain plan, but we try to limit what we do on the source database so that we don't impact it at all. So we have metrics and information in other sources. So Performance Advisor is running all the time. It's doing automatic anomaly detection. So we have that anomaly information in the Performance Advisor database. We're collecting time series metrics. So those time series metrics are available in Prometheus database. And then we ingest documentation. We vectorize it. It's available in a RAG pipeline. So the orchestrator can come in and decide which one of these agents it wants to use. Often it uses multiple of these agents to answer the question. And then all this is being handled by Gemini 2.5 right now. We want to build in an option where you can change models if you want. So what's the context for where we're coming from with Performance Advisor? So in the industry, even to this day, the general paradigm is we have 10, 20, or 100 different graphs. The user needs to know what are maximum values that need to be investigated. We need to know which graphs to correlate, and we need to know where to find them. So this takes deep expertise and also takes time. It can be frustrating and challenging. So our first goal with Performance Advisor was to simplify all of this. So we've simplified it all down to one graph, a cluster load graph. Along with that, we have automatic anomaly detection. And then what we're introducing is the AI assistant to guide the user through these recommendations. So like this is in Yugabyte. We have like multiple tabs, each have multiple graphs. If you look at Amazon's CloudWatch, multiple tabs, multiple graphs. And any like Grafana installation I look at, there's multiple tabs with multiple graphs. It's a lot to take on. So let's demo what we've done. So this is the Performance Advisor console page. And the main graph here is this top graph, the cluster load graph. So what's that mean? These bars represent the number of active connections to the cluster, and this is live right now. And the colors represent where those connections are spending time. Like green, for example, is probably the primary one. Green is connections that want to run on the CPU. But how much resources do we have with CPU? There's a dashed gray line here. It's the CPU capacity of the cluster. Let me zoom out. We'll see some more activity going on. So this dashed gray line, for example, here there's no demand for CPU. And then there's certain points where our CPU usage goes above the green. The green is the demand for CPU. How many connections want to run on the CPU? That's a demand. And the capacity is a dashed gray line. So when the demand for CPU goes above the dashed gray line, we know we have contention for the CPU. If we added more CPUs, it would run faster. And the different colors have other meanings, like red is locking, this orange is like I/O, purple is the backend's waiting for the client to consume the result set. And below this, we have the top queries. What queries are generating this load and creating load? And the bar to the left of them sort of represents the relative impact. So most of the load on this cluster is by that first statement, and we can see red in the bar, so it's running into locking issues. The next one is purple. This is where the backend's probably generate a large result set, and it's waiting for the client to consume that result set. And the next one, we have some orange, which is the dark yellow, which is like I/O, so it's waiting on I/O. So while all of this is way easier than looking at 100 different graphs, it still takes some expertise to understand what the content of this page is. What does that top graph mean? What are those different colors? So that's where we've introduced Agentic AI. So I can click this Ask AI button on the top left, and we get the copilot, the AI assistant. So let's ask it some questions. So the first question I'm going to ask is, let me zoom in on this. Oh, it already answered. Let's see. So what I asked was, what are the top 10 slowest queries? So I said, can you give me a list of the top 10 slow SQL queries that I should analyze for optimization over the last 6 hours? Comes up with a table. I can go over to the right-hand side of the table. I see the metrics like average latency, P90, P99, how many rows are returned by the query on average, when's the last time it was seen. And after it gives this table, it says, would you like me to start a detailed analysis of the query one? So I said yes, and now it's processing that. A few things about this interface are, on the top right, we have a downloaded chat. So then I can download the whole chat to PDF, and I can send it to anybody. On the left, we have new chat. So if I want to run a new query on a different subject, and I want to keep it separate and navigate back to it easily, I can start a new chat. And then we have like little icons below this. I can copy just this one response. I can copy that. I can give it a thumbs up or a thumbs down. I can read it out audibly, or I can share just this one response. And another neat thing is this little paperclip. Yushin talked about RAG implementation. This is like automatic RAG implementation. If I click on the paperclip and I have some documents about my application that nobody else would know, what I need to analyze my performance, I can click on the paperclip. It'll bring up a file browser. I can load up a file. It'll vectorize it and put it into the RAG pipeline so that the AI assistant can leverage that information. So here it came up with the first query. Here's our first query, insert into test table, and then we do a select max K and V from that test table. So it says what the query is trying to do, gets an explain plan, analyzes the explain plan, finds a sequential scan, which is basically a full table scan, does wait event analysis. This query is responsible for 20% of the load on the cluster. It's spending most of its time on locks. But what I'm most interested in are the recommendations. So it says, instead of using that subselect for max, just use a sequence number. So create a sequence, and then insert in the table with that sequence number. And this eliminates that full table scan to get the max values. Selecting max values from a subselect is generally an anti-pattern in databases. It says if you have to use the max for some reason, make sure there's indexes on the max. So there's two fields, K and V. If you're going to do that max, make sure there's an index. So last thing it says is, do you want me to analyze the next query? And this will take a minute. Like, whoops, I haven't even started it. So any questions on what's happening so far? Whoops. So while it's processing this one, we can look at some previous responses. Well, here's an example of where I ask about a performance. So I asked the AI, what does my archives old routine job do in fleet track application? It's like, I'm doing performance analysis. I don't know what this is. Suggest looking at the docs. But then I upload a document about my application. And then I ask the question again. And then it says it knows the answer. Based on the context provided, archives old routine is job that's scheduled, that archives historical data over the last 90 days. So I'm back in the question I just asked now is to analyze the second query. It found the second query, talks about what the query does, runs an explain plan, analyzes the explain plan. Again, it found a sequential scan, or basically a full table scan. Does a weight event analysis. And again, what I'm interested is in the recommendations. So it says this query is basically spending its time on client weight, which means that the application or the end connection is slow on retrieving all the rows from the back end after the back end's already run the query and it has the row set. So this can happen for a number of reasons. But basically, what we also can see over here here's the Performance Advisor dashboard. We can see the metrics for the query. So like it's retrieving 1,000 rows. So a client generally doesn't need to be running a query all the time that does 1,000 rows. So that's a lot of data for the client to ingest. So this is causing wait time on the back end while it waits for the client to consume the records. So recommendations, this could be slow processing time on the application, inefficient data handling, like why are we sending these 1,000 rows? Generally, we probably only need the first 10 or so. So also it suggests it sees a sequential scan or full table scan. So it suggests a range index, secondary index on the table to support that and get rid of the full table scan. And it gives the create statement for the instead of creating a secondary index, Yugabyte by default creates tables as hash partitioning, which is good for equality lookups. But if I'm doing a range scan, if I'm doing a range query, like here's a range query where a field between two values. A hash index that can only look up equality can't support this. So we need to create a secondary index, a range index, so it can support the range-based predicate filters. Here's query 3. So we can keep going on through these. I'll ask some different questions, but we can keep going through that top 10, and it'll analyze every single one of them. So this first one, select title from heavy payloads text, where ID plus a $2 variable equals $1. What this query does, explain plan, analysis, again, it finds a full table scan, weight analysis. Well, what I'm interested in is the recommendations. So what it says basically is we're using another anti-pattern. So in the predicate filter, we have a field plus a value. Well, that blocks us from using an index. But a simple solution to that is just putting that variable $2 on the right-hand side of the quality. And that way we can use the index and get rid of that full table scan. So I'm going to open up another dialog box. You can ask some other questions. So Performance Advisor collects anomalies, but how do I deal with these anomalies? So I ask it, I said provide details about each type of anomaly faced and suggest recommendations for fixing these anomalies. Oh, so yeah, the anomalies. On this Performance Advisor dashboard, by default, we show the top queries. But there's another tab called Anomalies. So we do automatic anomaly detection. And this is basically a Gantt chart that shows when those anomalies have been found. They're grouped into 4 different groups. Each group we can expand. So like uneven tablet I/O is basically a hot tablet. It shows us which tables have the hot tablets. So here, the AI is given an analysis of the anomalies. So it finds a high node connection, which is true because instead of using the smart driver, I sent all my connections to one node, which is an anti-pattern. We want to balance those connections across the load, so we can spread the load evenly. So I should be using the smart driver. It found a hot tablet. This is the table hot tablet is in, when it happened. So we want to analyze the distribution of data in that table to make sure that the tablets are evenly distributed. Again, a large tablet, it's like this is created on purpose, but one of the tablets has much more data than the rest of them. When it happened, basically want to check on like table splitting G flags to make sure the tablets are split evenly. And then it found a redundant index. And it's just saying, if confirm that these are really redundant indexes, and then drop them because they're taking up overhead. So that's a real quick run through. We can ask more questions, and we'll have this running in the demo ground. But just a review. So AI is helping us shift from complexity to clarity. So we went from 100 graphs down to 1 graph, 1 page, and still we need to know some knowledge. And now we have AI assistants to guide us through that. So we'll have these things running in the demo grounds after lunch. So like Yushin talked about RAG pipelines, we'll have that. We'll have Voyager, live migration with the copilot. We'll have Performance Advisor with its AI copilot. And then Station 4 will be managing distributed databases. So thank you, and bon appetit. Anybody have any questions?
We do. Thanks for that. I think it's really cool. I can't wait for it to come out in GA. Let me know when that happens.
Looking forward to that, yeah.
Oh, I got 4 now. Does it save narratives to replay or for audit?
Does it save narratives?
Narratives. Does it save the narratives that you're discussing with it for audit?
Not now. If that's a feature that somebody wants, automatic, we can work on that. Right now, we have the shares the whole dialogue, and you put it into a PDF, and you can pass it on, but it's not done automatically. It should be easy to set up if we wanted.
Yeah, I think so. Does Perf Advisor require additional licensing other than the base license?
Currently, no. Right now, it's deployed in Yugabyte Managed, or Aeon. So it's just a matter of contacting support if you want to run it. This might not last forever. There might be a point where it's charged for.
Yep. Does the Perf Advisor send metrics and queries for databases to a public LLM?
Well, no, not now. So Performance Advisor without the AI is either in, right now it's running in Aeon, or Yugabyte Managed, so it's all stored in Yugabyte infrastructure. Right now, the AI, which is not available, but if we did set that up like on a one-by-one basis for a customer, it's using Gemini 2.5, so it's going out. But we do want to offer the option of using a local LLM, but that's not there right now.
Good. Thanks, Kyle.
Okay.
Let's give him a round of applause.